Hi friends, a very good evening. Let me just check how the whole connection is working and then we'll start the session itself. Just give us a couple of minutes, right? So we'll just check if how everything is working. Yeah, I can hear myself. I can also see the screen that we have. So that sounds like a good deal. So let me just change it to my whole screen sharing. So I hope everybody can see my screen now. Okay, so this looks good. Okay, we have a bunch of people. The connection is excellent. Okay, so as usual, we are a few minutes early. So let's wait for everyone to join in. So let's wait for a few minutes. Hey, good evening, folks. Thank you for joining in. And we'll start the session at 7 p.m. sharp. So let's wait for a few minutes. I can also answer a couple of questions if there are any that students have. I'll try to answer at least a couple if I can, right? So based on the time. But we'll start the session itself at 7 p.m. sharp. Let me just check. Okay, the connection quality is good. The speed is good. Okay, everything looks good. So no issues whatsoever. Hey folks, good evening. So, okay, let me just mute this. I hope I have the chat window. Yeah, so this is looking good. I have the chat window here also. Good, that's good. Hey folks, thank you for joining in. Again, as I just mentioned a couple of minutes back, we'll start the session at sharp 7 p.m. Let's wait for others to join in because the session is supposed to start at 7 p.m. And if you have any questions, feel free to ask in the chat window. I'll try to answer a couple of them before the session starts. So when I do revision, it feels boring kind of learning the same topic again. So the simple solution to that is don't revise going through your notes, revise by going through problems because problems are always more exciting, right? It's a very simple solution. When you do revision, if you are very confident about the subject, just try to revise it in a couple of minutes take a concept because you have your notes, your highlights. Let's take one concept, like say recursion, right? So revise it in a few minutes, maybe maximum half an hour, go back, solve a bunch of problems. That will be far more exciting, right? So it's a very simple solution. Everything is uploaded, right? Rajat, everything is uploaded. So all the content is there. We are redoing DLD. We have started redoing DLD already. We will be uploading it soon, but we should have it ready, completed in early June. Okay. Sir, I want first rank. What should I do? I mean, come on. Let's be realistic here. The difference between the first rank and the 100th rank is a random bunch of mistakes that you do. If anybody says you can get first rank, I mean, I think it is more foolish than said. Again, I know this firsthand because I've gotten a pretty good rank, but I think I got a little lucky. So again, between getting the first rank, it's very important to understand that between getting the first rank and the 50th rank, there is not much of a difference in the institution that you go to. You will be able to go to any major institution, right? So instead of trying to get first rank, because the difference between the first ranker and the 50th ranker probably is just a couple of questions. It's just very few questions actually. So I think in the long term, again, you might feel great that, okay, I got all India first rank, all that stuff. But look at your career, look at your life in the long run. So if you look at it in the long run, with first rank to 50th rank, you can go to IISc, you can go to IITB or any institution of your choice. And when you go to IISc, nobody cares whether you're a first ranker or the 30th ranker. It really doesn't matter. Okay, when IISc placements comes, your skills, your knowledge matter. Nobody cares. Nobody asked me what is your gate rank till now, to be honest with you. Okay, once I got into IISc, nobody cares. It's your performance, your CGPA at IISc or IIT Bombay or any other institution that you choose, the subjects you have taken, the knowledge you have gained, the real world experiences that you have gained, that's what matters. So instead of trying to get first rank, try to be good so that you're in the first 50 ranks. This is a more realistic thing. Okay, and this is all, again, the difference between the first ranker. I know this because I got second rank once. And when we worked backwards, the difference between the first ranker and second ranker was just 0.25 marks, right? And this was a question paper of 150 marks. And the difference between the second ranker and the third ranker, again, the third ranker when I took GATE is a great friend of mine. He's now doing his PhD at MIT. The difference between both of us was, I think, half a mark or something like that. Right? It's just one silly mistake that pushed somebody from first rank to third rank. But in the long run, it really doesn't matter. So instead of saying, I want first rank, try to be good enough so that you're in the first 50 ranks. And it doesn't matter beyond that. Okay, sounds good. Let's get into this discussion. Let's get into the problem solving session itself. I'm sorry I may not be able to answer all the questions, but thankfully we have few of our teammates who also joined in, who will be contributing and answering some of the questions here, right? So, okay, so today is C programming. Let's get started. We have 10 problems and I would like to cover all of them. So let's get started. Here comes the first question. Here is your first question. Let me open the chat window. Okay, sorry for that, but just wanted to show you the chat window also. We'll also start the timer. Okay, let's take 1.5 minutes for this. Simple questions, nothing fancy. So let's take 90 seconds or 1.5 minutes for this. Again, when you have an answer, just like our previous sessions, please put it here. I'll explain the whole solution. Okay, I start seeing some answers. Again, please, it's not speed that matters, it's accuracy that matters more. So please revisit your answers and think twice before you put in an answer. Because gate C questions are slightly tricky. They're not hard, they're tricky. Okay, it's already 1.5 minutes, but let's take 30 more seconds because I see a lot of wrong answers, to be honest with you. I see a lot of wrong answers. Again, I see so many people putting in B. B is incorrect. Let me tell you that. I've double checked it. We've also executed it. We have executed every snippet of code to make sure that things are right. So B is not the right answer. So rethink. I'll give you 10 more seconds, rethink. Okay, so it's already 2 minutes. Again, this is a very, very common type of question that's asked in GATE. This question is not hard. This question is very simple. You have a 2D array here, right? You have a double pointer. It's a very simple question. It's just that it's tricky. I have seen over 90% of people have put answer as B. You can execute this code. It is not B. Okay, it is surely not B. I've double checked it. I've thought through it carefully also. Again, our team has double checked it. They've executed this code. The reason we gave such a question is because this is easy but tricky. If you are not careful, you'll mess it up. Okay, so let's go. So we have int I, simple. Okay, so A is basically a 2-dimensional array and you have these values, simple, right? This is your A0. This is your A1. Very simple stuff. The tricky part here is this. Look at this. This is a, what is this? If you want to read this in English, right? This is a 1D array. Look at this. This is a 1D array of, what is it an array of? It's a 1D array of double pointers. It's a 1D array of double pointers. That's important. It's not a 1D array of pointers. It's a 1D array of double pointers. That's the tricky thing here. That's what makes the whole problem tricky. When you say P equals to A, what happens? P will point to, so if you have A here somewhere in memory, right? So suppose this is your whole A in the memory, right? You have these 4 values, 1, 2, 3, and 4. This is your memory location. The moment you say P equals to A, P again, at the end of the day, P also stores the address of something, right? So this will work. The tricky part here is, what is this? This notation, again, the whole trick here is this 2 stars. Lot of people I know have gone for B because they think, okay, what is this? This is basically a pointer. Okay, I have a pointer here and I have two locations. So they think this whole thing will work and give us B. It will not give you B. The reason being, imagine if this line was different. If this line was slightly different, if this line was, let's say, int, okay, star P2. If this was this line, then what are we creating? We are creating an array of 1D pointers. Then the answer would be B. If this single line was like this, because what is a 2D array here, literally, if you think about it, right? So your 2D array actually has this whole structure. So if this snippet of code was not 1D array of double pointers, but 1D array of pointers, then this code would return B. That's very simple. But because this is, remember, this is an array of double pointers. Because this is double pointers, again, this is a standard way to imagine if this line was this. Okay, so let me pick a different color here. Okay, if this line was this, then this is basically using the pointer operations to print the values that you have in the 2D array A. But that's the tricky part. Just one single star messes up everything here, right? So this will not print. This will not print the values that you have in the 2D array because simple logic. It's a very simple logic here. The logic here is, again, so the way it will print is, it will print 1 here. Again, you can run this snippet of code. It will print whatever is there in this first value, which is A00. It will print that properly. But rest of the values it doesn't print. Because when you add, again, remember, when you add something to this, it is a pointer arithmetic that's going to kick in. And P itself, remember, what is P? P is a double pointer, not a single pointer. It's not an array of single pointers. It's an array of double pointers. So just one line, if this star did not exist, the answer would be B. By just adding one more pointer, we have made this question tricky. So the right answer here is actually C. Right? The right answer, again, because we're not given more options, it will print the last row. Certainly not. It will print all the values in the 2D array. No. It would have printed this if this star did not exist. It's not a compile time error. It will not give a compile time error because everything is the code itself from a pure syntactic viewpoint is correct. Right? So the correct answer here is C, and the mistake that many people commit, we intentionally gave this tricky question, is because of this additional star. Right? This additional star is what messes up everything. If this star, again, you can run this code. I've tested it. Our team also has tested it. If this star does not exist, B is the right answer. But if the star exists, again, you have to read this in English. Whenever you have code, at least my suggestion is, what is this? This is basically an array of double pointers. If this was an array of single pointers, then everything would work well. Because that's the logic behind a 2D array, right? So that's the tricky part here. Okay, so it's a tricky question, but a simple one. And I know many people will do this mistake. That's why, again, in gate, questions are tricky, not hard. Okay, so the output for this, if you run this code, the output will be 1 followed by 3 garbage values. You'll get 1. You'll print this first value here for sure. Because when I equals to 0, it'll print the first value that is there in this 2D array. But rest 3 values will be garbage. So it will actually print unknown and garbage values. This is the most appropriate answer, right? Sounds good. Again, we have tested all of this with GCC, which is the most widely used compiler. All the code that we have here, we have tested it with GCC. Okay, sounds good. So now let's go and check this. Okay, here comes the second question. Okay, again, 2 minutes. Let's start. Let's take 2.5 minutes. This is a slightly lengthy question. So let's take 2.5 minutes now. sorry, let me move this here. Okay, I was just typing one of the questions that students had. That's okay. I think I messed up the timer, so okay, I'll avoid answering the questions. Let our team answer the questions in the chat window. Okay, what is that? Okay, so let me read the question once. This is a good question. Okay, I see a bunch of answers here. There is some variability in the answers. Again, this is a simple question. It's not even that tricky actually. Okay, so let me stop the timer and get to the explanation, right? Again, we have intention. This is a simpler question, but let me explain step by step. Again, in gate, try to eliminate options because that will give you time. So here, if you notice, the first 4 outputs themselves are different. So if you can figure out which is the first output, you don't, again, if you read this code snippet, right, you have a printf here, you have 3 printfs here. If you just know what is a printf of this, because all these first 4 printfs are different, you're done, right? So this is a question which looks daunting, looks big, but the gate exam, the examination folks might only give it for 1 mark because you can eliminate options very quickly and you don't have to solve the whole problem in gate, right? In gate, if you can solve a problem faster, we should try and do it, right? Okay, so let's look at this. So we have a structure which contains a character and a character pointer. Cool. So here we have this, we have an array. So this is your array 0. This will be your array 1. C along with course is your array 2, right? So this is your array 2. This is your array 3. This is your array 4. Now it says, okay, it's creating a pointer P. It's pointing to array, which means P will now point to the very first element here, right? Again, P is a pointer of type structured data. Now it says P++. Now what will P point to? So if you think about it logically, okay, so your P is pointing to the 0th value here. So this whole thing will become your 0th one. This is your first, this is your second, this is your third, this is your fourth, right? Now P is pointing to the 0th element in this array ARR. Now when you do P plus 2, or P equals to P plus 2. When you execute this statement, what happens? P will start pointing to this location now. Okay, P will no more point to this. P will point to the structure which consists of C and course. Okay, till here we have executed. Now what do we want to print? %s, which means we want to print a string followed by a comma. And look at this here. Now in this, again, this is a prefix. This is a pre-increment and this is the arrow mark. Here comes your whole concept of operator precedence and basically operator precedence, right? So if you look at, let me show you the screen for operator precedence. I put it here just in case people have forgotten it. So what do we have? We have arrow mark, the arrow operator, right? Its precedence is higher than, look at this. We have prefix, right? If you go to our question here, where is our question here? Our question has, this is a prefix increment. This is a pre-increment, right? So this is a pre-increment and arrow. So now between pre-increment and arrow, which has the highest precedence? Arrow has the higher precedence than prefix increment or decrement. Look at this. Look at this. That's the important part. The postfix increment or decrement has the same precedence as arrow mark, but then you'll have to apply associativity rules, right? In our case, it's very simple. The arrow has higher precedence than prefix increment. So this will work as follows. So this will work as, so this is equivalent to this, right? P arrow C. Now remember, what is P pointing to? P was pointing to the third element in this structure. This is the 0th element, this is the first element, or in other words, this is the 0th element, first element, second element to be precise, okay. So P is pointing to the second element or at index 2 in this array ARR, right? Now P arrow C, because it's a structure pointer, right? So then P arrow C, what will P arrow C point to? P arrow C will point to this, right? P arrow C is basically C, right? Now that whatever we have here, we are incrementing that. Look at this, we are incrementing it, right? We are pre-incrementing it, not post-incrementing it. So whatever we have here, if you increment it, remember that this is a character pointer. C is a character pointer here. So if you increment it, this will point to O. So now we are doing percentage S. When you're doing percentage S with this, again, this is a character pointer, right? Remember that whatever we have now, PC is a character pointer. We've incremented it to point to O and we are saying printf percentage S. So it will print OURSE. So if you look at all these options, OURSE is here. So certainly option C has to be the correct option. You can eliminate all the other options. Very easily you can eliminate and C is the option here. It's very simple. In a gate question paper, this is a faster way of solving. But just in the interest of completeness, in case the options are such that they are very tricky, let's see how the other three statements also work. Okay, so it's very simple to determine by just running one statement here, we can say that C is the right option. But let's see how you got WEURSC also. Let's see that. Okay, now we have this next statement that we have is this. Okay, the second statement. Now, how does this work? This is, okay, so let's go step by step. So this will be P arrow C plus plus and then star. Okay, again, if you're not convinced with that, the order, again, the precedence and associativity are very, very important. Okay, look at this. Arrow has the higher precedence, then comes prefix, then comes your, again, the plus plus, the prefix and star, the indirection or dereference operator have the same thing. They're evaluated left to right. The associativity is left to right, right? So if you look at this snippet, where is our code? Yeah. So this line will be changed into P arrow C plus plus and then star, right? This whole thing has plus 2. Now let's see. P arrow C got incremented. So it was actually pointing to this now. Just in the previous line, the P arrow C, right, was pointing to this. Now P arrow C plus plus. Okay, let's go step by step here. P arrow C is pointing to OURSC. Now when we do plus plus to this, because it's a character pointer, it will point to URSC. Look at this, it will point to URSC. The star is a dereferencing type of operator, so value stored at that. So you will get U now. So this star of this whole thing, look at this, P arrow C was pointing to O, plus plus will make it point to U. The value starred, the star of this will basically return U here. So this whole snippet of code will return U plus 2. Now U is a character. Characters in C programming language can be interpreted as ASCII values. Via ASCII, you can interpret them as integers. Now when you do U plus 2, you get, after U, what do you have in alphabets? U, V, W, right? So you get W here because you're trying to print the character equivalent of it. U plus 2 is equal to W. So when you print it, it will print W. Again, this is slightly more tricky, but it's very good. Again, we could have given these options in a much more tricky fashion so that by just solving this, you can't answer. But we thought, let's keep it slightly easy, not too hard. Because otherwise this is too time taking, right? So first one we have done, second one we have done. Let's look at the third one. Okay, so what is the third one saying? It's saying P plus 2. Look at this, P plus 2. P is pointing, look at this, P itself is pointing to the second element now. P plus 2 will make it point to the fourth element now, right? This whole thing. So P will now point to this whole structure now. Okay, P plus 2, value stored at it. Look at this, P plus 2, the value stored at it, which means we get the whole array here. Sorry, we get the whole structure here. In that dot I, right? So what is I here? I is nothing but the char I here. So I will be E and we are doing percentage C, so it will print E. Very simple. Next, if you do percentage S P arrow C. Look at this, percentage S P arrow C. Now what happens here? When you do percentage S P arrow C, Look at this. P is still pointing to this. We just did P plus 2. We did not do P plus equals to 2. So P is still pointing to this. P is still pointing to this. P arrow C, because we changed this pointer. Look at this. We incremented these pointers here. Right? So P arrow C was pointing to the one starting from U, because we incremented it twice here. We incremented it here. We also incremented it here. So this character pointer, we incremented it twice. So it will be pointing to U. So if you print percentages P arrow C, it will print URSC. Again, running through all the 4 options is a good exercise in understanding precedence and associativity, right? It's a good example, but we kept it easy so that you can just run the first line and answer the whole thing, right? So it's a simple question. Again, given the options that we have given, it's a simple question, or else it would have been, harder. Okay. Again, again, if you're still confused, just rewatch this video later. Again, it's all in the P arrow C pointers that you have to be careful about. Okay, you have to be very careful step by step. Apply the rules of precedence and associativity. You can easily solve it. Okay. Again, a lot of you got it easy because we made the options easier. If they were a little tricky, this problem can be made quite tricky and hard. Not hard, tricky actually. Okay, so let's go to the third question now. Okay. I'll start the timer. Okay, let's take 60 seconds to solve this problem. This is a very simple problem. Again, some of the questions that I could not answer, thankfully some of our teammates are answering in the chat window. Again, I'm moving fast because we have 10 questions. We are still in the third question. So I'm slightly trying to move fast because we want to do this in 60 to 70 minutes. This is a very simple question. Okay, I see I see multiple answers, A, B, C, D. I see all 4 options here. Okay. Okay, so 60 seconds up. This is a very simple question. This is all about the nature of static. Look at this. Whatever you have as static variables, you have to initialize them to constants. You have to initialize them to constants. You can't initialize them to variables. That's very important. That's a fundamental property of C itself. Again, so if you don't initialize it to anything, the default value it is initialized to is 0. But if you initialize it, you can't initialize it to a variable. You have to initialize it to constant. So if you try to compile this code, you'll get a compile error. It's very simple, right? Static has this very simple logic that you should always initialize it to constant. If you don't do it also, it's okay. Its default value is, it's always by default initialized to 0. Right? But if you initialize it, please don't initialize it to a variable, and that's the tricky part here. Again, it's not rocket science. That's why I just gave 60 seconds. It's a very simple thing. Okay. So let's go to the next question now. Again, there are a few simple questions also. Okay, let me start the timer here. Let's take 90 seconds for this. The next question, we're on question 4 now. So let's take 90 seconds for this. Again, I am trying to speed up slightly. I'll try to explain reasonably well, but I want to also finish the 10 questions we have for C. I'll explain every solution, but I may not be able to answer every question in the comment section. Our team is doing a great job of trying to answer as many as possible in the chat window. Okay, so let's see the answer for this. So for question 4, This is also slightly tricky. It's not very hard actually. Okay, so let's take 30 more seconds because I don't see as many answers here. So let's take 30 more seconds. I see a few answers here, but let everybody put in their answers. I see A, B, C, D. I see all options here. So let's see. This is a slightly tricky question. Okay, so 2 minutes are up. So let me just pause the timer and get into the solution. So this question is all about macros, right? So if you're careful with macros, it's very simple. I see a wide spectrum of answers, but let's try to understand it, right? So the moment this is called, right? So what happens in the code, right? Macros are replaced, or so whenever we have these macros, whatever is there in the macro is pasted here. So this will actually become, because we are passing a++ and b++ here. So this whole, in this logic, you will get a++ and b++, right? So what you will get here is a++ greater than equal to b++ question mark. X is a++, right? Because it's a macro. Remember, it's not a function call, it's a macro. So you get a++, b++. So macros try to replace whatever you're passing in this snippet of code. So this is equivalent to this, logically speaking. Now with this, what is a here? A is 10, right? B is 20 now. So first this will be executed. Remember here that A is post incremented, B is post incremented, right? So then you have the greater than equal to. So obviously, see this is A, this is B, right? So greater than equal to will be false, right? But as remember, greater than equal to will be false, right? Which means we should only care about, so this will be executed. This will not be executed now, right? But also there is the increment that's happening. Look at this, A is getting post incremented here. So what happens to A? A will become 11. So obviously option D cannot be the option. First and foremost, let's eliminate options as we go, right? Now look at this. So the result L equals to this. Remember, what is L? L equals to this whole thing, right? That's important. So if L equals to this whole thing, then again, remember that B is going to get incremented twice. Remember that B is going to get incremented twice, right? B is getting incremented here. B is also getting incremented here. So the final value of B will be 22, right? Because this is post increment. This is also a post increment. Okay. So you have L equals to this. Now the tricky part, so B is getting incremented twice, so B has to be 22. So this can't be the answer. I'm just eliminating options for you. The trickiest part in this whole thing is what will be the value of largest. Okay, if we can figure that out, we are done. Look at this. When this whole thing is running, what again, look at this. When this statement was executed, remember when this whole statement got executed, right? So your L will be, because there is B++ here. This is a post increment operation, right? So your L will get only one B++, not two B++. So your L will be 21 and not 22, right? Because look at this. The tricky part here is at this whole thing, either this is picked or this is picked, but you have only post increments here. You don't have pre increments, right? So L will only see one incremented value, which means L will see 21 and not 22. So the values that you'll see here is 11, 22 and 21. Okay, so B is the correct answer here. This is all the trickiness about, again, there are only two parts in this. One is if you understand how macros work, again, whatever you have here gets pasted here literally. And then all you have is post increments, right? Again, if there were pre increments coupled with post increments, it would become much trickier, right? So one of our teammates created this question. It's a very good question. Okay, it's tricky. It's not hard. You have to be slightly careful. That's it. Okay, so let's go to the next question. So let's take 90 seconds for this. So we have tested this code at least on a couple of compilers. I've done it on my computer. Our team also checked it on online compilers. So we have been careful to avoid obvious mistakes with output. So most likely the outputs that we have are compiler independent as far as what we checked. Okay, so I see a few answers here. Let me see. Okay. So since everybody hasn't put in the answer, let's take 30 more seconds, right? Again, these are very typical of gate questions. And you'll see some of these just for 1 mark also. So I see A, C, D. I see all options here. So let's see what... This is again a precedence type of thing. Okay. So let me stop the timer here and let's go into the solution. Again, this is also those slightly tricky. Again, most gate questions that we see are not hard. They're simple but tricky. Okay, so you have I. So look at this. This is the expression that you are evaluating, right? At the end of the day, this is what you care about. So you have I plus plus. I is -1. So you have -1 plus plus, right? And you have ampersand ampersand, right? You have J plus plus. J is -1. -1 plus plus. You have ampersand ampersand. K plus plus is 0 plus plus. And you have OR. You have L plus plus. What is L here? L is 2. So 2 plus plus. Now, if you recall the precedence of operators, let me show you that screen here. The logical AND has a higher precedence than the logical OR. Okay, the double AND has a higher precedence than the OR, right? Double ampersand. So obviously, logically thinking, where is it? Okay, so this is here. So this will execute first. This whole thing will execute first. Right, so this whole thing will execute first and then everything will work. Now, as far as C programming language is concerned, again, this is where I got a little confused because I work with so many programming languages on day-to-day basis, is C thinks 0 as false, rest everything as true, right? So there are some programming languages that do not follow this simple rule. So if 0 is false and rest everything is true, this is true. There is no short circuiting happening because this is true. This is also true. No short circuiting happening. This is true. This is true. Only this is false. Because this, again, this will execute. This will execute. This will execute. All three of them will execute. So this will be true. This will be true. This will be false. Again, why are these two true? Because they're post increments. They are not pre increments. So as far as this expression is concerned, we'll only be using -1. -1 logical AND, -1 logical AND 0. So all these three statements will get executed. There is no short circuiting. So what happens now? So I anyway will get post increment. So I will become 0. J will get post increment. So J will become 0. Then K will get post increment. So K will become 1. This whole thing has become false, right? So this whole thing is 0 or 2 plus plus. Again, 2 is true. False, again, this is equivalent to false. False or true is true. Right? Simple. So your M here will be true, or in other words, your M will be 1. Right? Your M will be 1. Your L also will get incremented by 1. So L will be 3. So you have, when you're printing I, J, K, L, M, right? So 0, 0, 1, 3, 1. Right? 0, 0, 1, 3, 1. Option A. It's simple here. Again, this is one of those simple questions. If you can break it down, if you can just think through it from the post increment, the simple logic, it's actually fairly simple, right? Again, we are trying to give some simple problems, slightly tricky problems, so that you get used to a wide spectrum of problems in the GATE exam, right? Again, as we progress through these sessions, we'll make them slightly harder, slightly, okay? Okay, so let's go into this question now. So let's take 90 seconds, or if you want, okay, 2 minutes. Okay, let's take 2 minutes for this because some people are asking for a little more time. So let's take Okay, I see a few people putting in the answers. Oh, sorry, let me put in the timer. I forgot the timer, sorry. Okay, so let's take some 45 more seconds. You have to be slightly careful with the recursion here. I see all options here, B, C, D, except I think people are picking every other option. Recursion, you have to be slightly careful. Okay, so I see a few options. So let's move into solve it, right? This is a standard, straightforward recursion problem. Nothing tricky, nothing fancy. You have recur 11, right, that you're calling, and you want to finally print this value, whatever is the value of C. So, right, so recur 11, it goes into this function, right? So you have 11 here. If 11 divided by 2 is not equals to 0, again, remember that 11 here is an integer, right? So automatic flooring will happen here. Right, so you have 11 by 2, because this is integer division. 11 by 2 is not equals to 0. Then it will say return recur n by 2 multiplied by this. So recur n by 2. So this will call recur n by 2. 11 by 2 is 5. Right, because it's all integer division only. There is no floating point operations here. So recur 5 into 10 plus num percentile 2. So what is num? Num here itself is 11. 11 modulo 2 is 1, right? So this is what you get. Now you have to solve recur 5. Again, this is going to call the recursion again. Again, 5 by 2 is not equals to 0. So we'll execute this statement. So this will call recur 5 by 2 is 2, because it's integer division, multiplied by 10 into 10 plus num is 5. 5 modulo 2 is 1. So this is calling recur 2. Now what will recur 2 call? 2 will go in as input. 2 by 2 is 1, not 0. So it will again go into this recursion loop. It will say recur 1, because 2 by 1 is 1. Recur 1 multiplied by 10 plus num modulo 2. 2 modulo 2 is 0. You have to just be careful. So what is recur 1? When 1 goes here, 1 by 2 is 0. Right? If it's not equals to 0, go into this, or else return 1. So this will actually, so now so we have gone into the recursion tree. Let's go back up. So recur 1 is 1, right? 1 into 10 is 10. 10 plus 0 is 0. So this will return 10 here. So you get 10 here. 10 into 10 plus 1, right? This is 101. So this will return 101 back here. So this will return 101. So 101 into 10, which is 1010 plus 1. So it is 1011. That's what the value of C is. And when you print C, you'll get one second. You'll get 1011. Yeah, option D is the right option. It's simple. Again, this is not at all tricky. It's very simple recursion. You just follow the code. You understand how recursion logic works. It's a straightforward question. Right? But questions like these have been asked in GATE in the previous years. Very simple recursion code, nothing fancy. Okay, so let's go to the 7th problem now. Okay, so let me zoom this out a little so that everybody can see the question. Okay. Let's take 3 minutes for this. This is slightly lengthy. So let's take 3 minutes. It's not hard. You can actually solve it in 1.5 minutes also. Again, please remember that this is all about dynamic scoping. Most modern programming languages don't have dynamic scoping, but assuming that we have dynamic scoping, you have to answer this question. Let's take 3 minutes, as I mentioned earlier. So please keep in mind dynamic scoping. Okay, I see a few answers here. Again, somebody is asking a question about AI course. Sorry, we want to keep track. This discussion is about C programming for Gate. If you have any questions, please email us. We'll respond to that. Right? Sorry, we want to stay to the topic of discussion today because it's unfair for other students. Okay, I see a spectrum of answers. I see A, B, C, D, all 4 of them. Okay. Again, dynamic scoping is the key here. If you execute this on GCC, because a typical C programming language does not use dynamic scoping, you'll not get the answer here. But assuming that we use dynamic scoping is the question. Okay, I see all the options here. Okay, it's already 3 minutes, so I've seen a lot of you have answered. Some of them certainly incorrect because people have, I see options A, B, C, D, all 4 of them. So let's go through it. Okay, I hope all of you know the basics of dynamic scoping. Again, in these question answer sessions, we'll not be able to cover theoretical concepts. So, okay, so let's see. So that's why I have mentioned earlier also that if you input this code to a modern C compiler, C does not use dynamic scoping. That's the tricky part here. So if you put it into a code, you won't get this answer. Okay, so you have to assume dynamic scoping. So let's go here. So you have A and B as global. So let's write down the whole flow. You have global A equals to 5, B equals to 4. This is the global scope, right? Now what happens? Main gets called. You are printing A, right? So this will print 5 first and foremost. Cool. This will print 5. Then we are calling function 2. Again, from global, we are calling main, right? Remember that global calls main. Basically, you have the global scope. Once the global scope is done, you get your main, right? So you're calling main function, because for dynamic scoping, the order of function calls is very important to understand what variable is being used. That's the tricky part here, right? So you have your main here. Then what happens? You have function 2 being called. So main calls function 2. I'll just write F2 here instead of writing whole function 2. So we go and execute function 2. In function 2, we have A equals to 3. Cool. We have A equals to 3. But B is not initialized. So the B it's saying B equals to 5. But there is no local variable which is B here within this function. So it will actually use the B that is there in its parent function which called it. That's what dynamic scoping is all about, right? So we go and check what is there in main. Main also does not have a local A and B, right? So what does it do? Because it doesn't have this, it will go here. It will go to its parent, right? So now what happens? There is B here, B equals to 5. The moment we have B equals to 5, this 4 got changed to, we're calling function 2 first, right? Yeah, we're calling function 2 first. Okay. Okay, so it goes, B becomes 5. Okay, so now let's see what happens now. Then we are saying, okay, so B became 5 now. Cool. Because there is no local B here. There is no local value of b. It went to its it went to the function that called it to the global scope. Okay. Then we are calling function 1. So this calls function 1 now. So let me write this. So this calls function 1 now. When it calls function 1, what happens? You have b equals to 7. So there is a local b that is equals to 7 here, and a equals to 2. So what does it do? It goes to its parent now, because there is no local a which is created here. There is no local variable a that is created here. So a equals to 2 basically means this will now go to its parent and it will make this a equals to 2. Right? That's what happens, right? It will go and make, one second, it is calling function 2, which calls function 1. Okay, so it makes this a equals to 2. Okay, now it prints. So first thing it prints is 5. So all these cases are true. Again, none of these also can be an answer. Okay, so then it prints a and b. So what is the value of a? A is 2 now. B is 7. So 5, 2, 7. So let me write down the sequence here. 5, 2, 7 till now. Then it says b equals to b plus a. But that's a local b that we are talking about, because there is a local b here. So locally b becomes 9 now. Right? So local b, not the global b. The local b becomes 9. Cool. Then this function is executed. We come back here. Then we are printing a and b now. Now we are back in function 2. In function 2, we are printing a and b. So what will a be now? A will be 2. So we'll print 2 here. Right? Because there is a local a here and we are printing b. But there is no local b. So we keep going back. So it will print 5. So now if you start looking at this, this says 52735, so this can't be the answer. This says 52735, this can't be the answer. If anything, B or D. Again, you can't say B is the answer now, because you still have some more printf statements, right? So 52725, till here everything is okay. Till here everything is okay. We have printed this, we are back here. Okay, but we have to be careful that the rest of them also are correct, because none of these also can be an option. Especially when you have none of this, you have to run through the whole thing. You have no shortcuts there. Okay, so let's go through this now. Okay, now we are back here. It says printf AB. Now there is no local AB in main, so it will go and print from the global, because the global scope now kicks in. So you print 5, cool. So this line prints 5, cool. Next you're calling function 1 now. Now again, this whole diagram will change. Okay, so let me just, okay, so till here we are done. Sorry, till here we are done. 2 5s are also done, right? So let me, okay, 2 5s are also done. So these two are also done. Now we are at this point. Again, we have the global scope. Oh, I forgot. Okay, I erased those values, right? Okay, we are back in main. So let me just erase this. Okay, because these functions completed. Okay, so we are back in main. Okay, these are the values that we have here. And then it's calling function 1. So we go to function 1 now. Okay, we go to function 1. Function 1 has a local b equals to 7. It has an a equals to 2. Because there is no local a, it goes to main. Main also doesn't have a local a. It goes to this and it changes this a equals to 5 to a equals to 2. Right? Because that's the statement. Then it prints a and b. So if it prints a and b, what should it be? A is 2. There is a local b. So it will be 2 and 7. Cool. Then what happens? B equals to a plus b. But there is a local b here. So this local b becomes 9. And then we come out of the function. Okay, so this is also executed. Finally, we have a printf statement where we are printing a and b. So here in the main, there are no local a and b. So we'll print the global a and b. And those values will be 2 and 5. So B satisfies the whole thing. So B is the right answer. Right? So again, the trick here is all about dynamic scoping. In dynamic scoping, you should always follow the function call sequence to find which of these variables is in the scope. Again, dynamic scoping is very, 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 very nightmarish from a software engineering perspective. Thankfully, most modern languages got away from dynamic scoping. Otherwise, it's a mess. It's so hard to debug these programs which have dynamic scoping. Thankfully, none of them, thankfully, we don't have it. Right? So the right answer here is B. We've eliminated A, we have eliminated C quickly, but since there is none of these also, we have to be careful to ensure that B, the whole output of B is the correct output. Right? That's all. Cool. So this is a good question about dynamic scoping. So let's go to the next question now. Okay, let's take 90 seconds for this. This is a simple question. This is a simple question. Okay, I see a lot of answers here. I see A, B, C, D, all options here. Just think through it. It's actually a very simple problem. Again, this is a slightly tricky but a simple problem actually. Again, I hope all of you know that 65 integer corresponds to capital A, right? The ASCII value of capital A is 65. So when you have the switch, one of the most important parts of switch is no two cases should be the same. If two cases are the same, that creates an error. So here this character A equals to 65. Remember, your val is 65. This A is 65. Now when you evaluate this, what do you get? This is a numeric expression. 8 cross 8 is 64 plus 1. This is also 65. So when this code gets compiled, look at this, when this code gets compiled, within the switch, it sees that this is integer 65. This is also integer 65. So you have two cases. You have two cases with the same value here, and that creates a compile time error, because at compiling itself, C tries to ensure that the cases that you have here, I mean, of course, it can't always do it, but what we have here is a constant. What we have here is also a constant expression which can be evaluated at compile time itself, right? It's not a variable, it's a constant that we have here, right? So you have A and you have 65 here, because both of them have the same thing. Switch with the same value here for two case statements is a compile time error. Simple, right? So you just have to know that fact about switch. And you have to know the fact that capital A in ASCII is 65. If you know this, it's a straightforward solution. Okay. Cool. So let's go to the next question. Again, somebody is asking to repeat the 7th question. Again, this video will be available on YouTube. You can watch it later. If there is any question, please put it in the comment section. We will respond. Again, for the 7th question, I think the confusion is all about dynamic scoping and static scoping. I've mentioned 3 times that it's using dynamic scoping. I think that's the tricky part. Okay, so I forgot to mention, sorry. So let's take 90 seconds for this. This is also a simple question. Okay, let's see the... Okay, this is straightforward. So 30 more seconds. Thanks to all the mentors at Gate Applied course who are resolving some of the questions in the chat window. Oh, so a lot of people have answered. It's already 90 seconds up. So let's go into the solution. Again, the key here that you have to realize here is, what does printf return? Printf returns a number of characters printed, right? So let's look at this first thing here. So what does this do? Int string length ABC. String length because you have string.h. That's perfectly all right. This is basically 3. So what does this print? This prints 3 followed by space, followed by A, followed by space, B, space, C. Followed by space, I'm sorry. There is a space here, space here, space here, space here. right? So it actually prints 3 ABC. So obviously D, first this is the print statement that is getting called, right? So D can't be the answer. Rest all of them have 3 ABC. But this printf, look at this, this printf returns something, right? What does this return? Whatever this returns gets printed here. This printf returns the number of characters that it printed. How many characters did it print? 3 space A space B space C space. So total of 8 characters. So this will return 8. So what is being printed here? 8 and a space. Look at this. So 8, so this can't be the answer now. It can be any one of these two now. So you have 3 space A space B space C space 8, right? And then there is a space here. Again, how many characters? So this will print 8. This will print a space, right? So how many characters are printed here? 2 characters are printed. So R will be 2, right? R will be 2. Now finally you are printing R. So you get 2 here. So option B is the right option. So in this whole thing, you just have to know this function called strlen, which is very straightforward. And you have to know that printf actually returns the number of characters printed and the order in which these functions will execute, because this is a nested printf within a printf, right? It's just a nested function call. That's it. Okay. So we have the last question. Somebody is asking, when does this session get over? We'll finish this as soon as the 10th question is over. We wanted it to be a 1 hour session, but this is a simple, straightforward question. So we'll finish this in about 5 minutes. So we try to keep all these sessions to be 60-minute sessions. That's why I had to rush in between a little. While I tried to explain the concepts, I could not answer all the questions in the chat window because people want to finish these 10 questions. They have other work post 8 p.m. So we have to do justice to them also. This is a good question. It's a simple question. This is a simple question. I see a lot of people putting in the answer. It's simple. Let's take another 20 seconds and then I'll explain the answer. There seems to be a little confusion in the options. Okay, so it's very simple. Look at this. You have this string, right? So you have this whole string in a character array, and you have I equals to 0. This loop, what does it do? It's checking for the /0. It's simply looking for the /0. So I'm sorry. This is index 0, 1, 2, so on and so forth, index 9. And by default, /0 gets added in index 10. So by the end of this loop, your I will be equal to 10. That's important. By the end of this loop, your I equals to 10. Because at the 10th index, it will actually find the /0, right? Which is the end of the string here. So I equals to I minus 6, which means I equals to 4 now. So Si equals to /0. So you have your quarantine, right? So 0, 1, 2, 3, 4. So what is it doing? It's replacing this A with /0. So when it replaces this A with /0, and now it's saying just printf S. So how does the string work? It keeps going through till the time it encounters /0. So remember, the A got replaced with /0. So when it tries to print this whole thing, the moment it encounters /0, it knows that it's the end of the string. So it will print QUAR. So option B is the right option here. That's all, right? Very simple. Again, we have intentionally given some easy questions and some tricky questions. Some of you may find that the tricky questions are little hard, but especially the concept of, if you recall the concept of precedence, again, we asked some questions around precedence, associativity, about pointer operations. Again, we have not asked slightly complex pointer stuff. We have asked fairly straightforward pointer stuff. Again, as we progress through these sessions, as we come closer to the exam, we'll increase the hardness from easy to slightly medium, but we'll keep the trickiness the same. No point doing very hard questions for GATE because GATE questions are seldom hard. Less than 2% of GATE questions are actually hard, right? They're often tricky, especially from the last 5 years. There are a few outlier years where the question paper was very hard, but most of the times it is this. They're tricky, they're not hard, right? So I hope you all enjoyed this. Again, unfortunately, I could not answer all the questions that are there on the chat window. Some of our mentors and teammates have answered some of the questions. Anything that you want things to be explained again, this video will be available on YouTube. Please watch the video. Put your questions in the comment section. We'll try to answer as many as possible. We'll do our best. And seldom means less often. Somebody says, what does seldom mean? Seldom means less often. Okay. They're asked very few times. Seldom is the opposite of often. Okay. I hope this session, you found this session interesting and fun. And we'll announce the next sessions. Again, we also did this session on Wednesday with one of our students who is now a scientist at Baba Atomic Research Center. Hope you guys enjoyed it. We'll try and conduct more sessions like that in the near future. We'll make the announcement for the sessions for next week, hopefully by Sunday or early Monday morning. Okay. Thank you very much, folks. Thank you for joining in. Bye-bye.